this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 6-1 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to graph transformations of exponential functions. And so what I'm going to be doing is I'm actually going to be doing a lot of this on Desmos, but I wanted to talk about the transformations real quick so you know what to expect. So the transformations for exponentials work the exact same way as every other transformation we've done. All right, so anything outside the grouping symbol, such as h and k, will actually be some kind of vertical change. Now anything inside the grouping symbol, which we're using the exponential here as a grouping symbol, this is going to be a horizontal change. All right, so then we have to look at what type of actions happening. Is it multiplication or is it addition or subtraction? Okay. Now if it's multiplication, there's 3 jobs that it does. If I'm multiplying by a negative number, I'm reflecting it vertically. If the actual value of that number is less than 1 or greater than 0, I'm doing a vertical compression. That means I'm squishing the graph down. If that actual number is bigger than 1, I'm doing a vertical stretch. Now, this is also going to introduce a b here. This b does a change horizontally as well that feels a little bit backwards. I'm not going to go into too much detail on it, but understand if you have a negative x here, it's going to be a horizontal reflection. We don't often cover horizontal reflections, stretch, or compressions. It's very, very rare. So Savvas might get into them a little bit, like they kind of surprise us in part B here, which is why I'm mentioning it. But often we do not touch that. Okay. So now let's talk about h and k, where we're adding and subtracting. So these are both going to be some kind of translation. But what it's going to do is it's going to take us in 4 cardinal directions. So the horizontal translation, right, is going to take us either left or right. And the vertical translation is either going to take us up or down. Now the way that you tell is in this equation we have a plus k. So because it's positive, the k is going to behave the way you would think. So if you add a number, you go up, and if you subtract a number, you go down. But because our equation has a minus sign in it where the h is, that causes it to kind of flip the direction you feel like it should go. So x minus h, you'd think it would go towards the negative side, which is to the left, but because of the minus, it's actually going to go to the right. And x plus h, you feel like should go to the right because the positive numbers are to the right, but the minus makes it go left. So just be aware that horizontal changes feel backwards. All right, now to spare you from seeing me draw this, which I made my students watch me draw it, I'm actually going to pop over to Desmos and let's talk about these transformations. So the first 2 of these are dealing with the parent function, f of x equals 3 to the x. I just want to zoom out my graph just a little. I hate when it counts by 2's. Now notice the y-intercept on this graph is at 0, 1. So when I'm graphing these, what I tend to do is first look for where the asymptote should be, and then look for any translations, any stretches or compressions that should happen. Okay, so because nothing's being added or subtracted here, my asymptote is at y equals 0. And so this anchor point is 1 unit up from that asymptote. Okay. So the first part of this question talks about what if it's a negative 3 to the x. Well, that negative being in front of it is a vertical reflection. So what this is going to do is this is going to flip the graph upside down. So notice my horizontal asymptote didn't change at all, but instead of going up by 1, it went down by 1. Okay, so that's something to consider. Now on our next one, they take this 3 to the x and they're subtracting 4. And that 4 is outside the grouping symbol, which makes it a k value. And so if you look at this, you could see that the graph was shifted down by 4. Which the easier, like it's hard to see it beyond the 0, right? But the easier parts to see it are on our intercepts, our y-intercepts. But you could also see it by if you go far enough to the left, right, where the asymptotes are, it's really easy to see that 4 there. So that's usually what I look for. What I look for. I'm sorry. Now the kind of key thing to notice here is it shifted our asymptote down, right? So our asymptote is no longer at y equals 0, and it also gave us an x-intercept. So just be aware that's a thing. Now the try it portion of this is dealing with the parent function of 5 to the x. Now I'm going to compare these two parent functions. Do you see how the 5 to the x, which is the purple one, is steeper than the 3 to the x, which was the red one? So the bigger number that this base is, the steeper our exponential is, which makes sense, right? If I'm multiplying 5 over and over and over, it's going to grow quicker than multiplying by 3 over and over and over because it's a bigger number. But that's something to look at. Sometimes people will see two graphs that have different bases like this, and they'll think there's some kind of stretch or compression happening. They make that mistake. And so really you need to know what kind of base is going on before you can talk about transformations. So on they call it little letter A. I used a new letter. On little letter A, they take that 5 and they're adding a 3 inside the exponent. So changing the exponent is a horizontal change, and remember it feels backwards. So in this case, it's actually translating to the left by 3, which is a little harder to see unless you have some kind of anchor point. So like I know the anchor point 1, 5, because if I take 5 to the first power, it's 5. And you could see that jump here, 1, 2, 3. If I go to my anchor point here at the intercept, you could see the 1, 2, 3. So sometimes the horizontal changes can be hard to see because there aren't very many anchor points that fit on the graph, and you have to kind of know where to look. So the y-intercept is a great place to look, and whatever the first power is always a good place to look. Now this last one is the one I kind of warned you about, right? We don't really do very many horizontal changes where there's a number in front of x. But sometimes we encounter those here, so let me show you what it looks like. So instead of becoming an increasing function, it is now a decreasing function. Right? You could see where we reflect that graph across the y-axis, right? So if ever you have a negative in front of x there, you'll have that horizontal reflection. Just be prepared. Usually there's not a number in front of that x, and that's something that's like a whole other can of worms to discuss at a later date. But there you have it, y'all. That is graphing the transformations of exponential functions. Until next time.